So welcome everyone to our weekly workshop. What is today? 20th of March. Springtime in Virginia. So last week we talked about introductory cryptography challenges, and that was fun. This week we're going to talk about networking challenges, and I'm going to talk a little bit about Wireshark along the way. So Wireshark is a tool that we can use to help us with networking challenges, because lots of networking challenges have something to do with some kind of a network packet capture, whether that's a live packet capture or a recorded, packet capture file. So we're going to take a look at some Wireshark today, and we're going to look at some walkthroughs for some networking challenges. So that's what we've done the last couple of weeks is done walkthroughs through some sort of introductory challenges. And I'm going to see how far we get today. I may talk more about networking challenges next week, just because I'm not sure how far I'm going to get talking about Wireshark. I want to do this in about 20 or 30 minutes, so I'm not going to talk for too long. And so we may do some more networking challenges next week, so we can get into some challenges that are not way more difficult, but just more introductory networking challenges. So that's the plan for this week and maybe next week, and I'll sort of decide when we finish how far I got. Never quite sure. So this, I put up this slide every week. There's a CTF that you can join if you haven't already, and it's vacr.io/weekly workshop. If you go to that URL, that's obviously a shortened URL for a workshop CTF that we have set up. And if you already signed up for it, then you just log in and you can solve some challenges along with me today. Or if you've not signed up for it, you can click on that link and you can self-register and you can start playing. I'll mention again that you'll see some challenges move around each week, right? Because I don't like today I added and removed some networking challenges because I wanted to make some particular points about some stuff that I knew I wanted to make, and so I wanted to have the right challenges in here to make those points. So the challenges may change week to week, but that just gives you more opportunity to solve more stuff, so it should be good. Just a warning. Okay, today we're going to talk about networking challenges, and so these are perhaps pretty obviously challenges related to networking concepts, devices, and protocols. So a lot of it is network protocols: TCP/IP, DNS, HTTP, Telnet, FTP, etc. There's lots of networking protocols. I listed some of the very sort of widely used and well-known protocols. What you'll see in some more advanced networking challenges is you'll see network protocols that you've never seen before, right? So like I took my students, I taught up in New York for many years, and I took my students to a CTF, and they were thrown on a SCADA network, and it was a live SCADA network, and it was running Modbus. And these students, they were college students, they couldn't even spell Modbus, right? So they on the fly they had to learn this new Modbus protocol and then solve these challenges around it. And it was a super good learning experience for the students. That's what you'll see in some more advanced challenges, right? The protocols that you've never even seen or heard of before. But for these introductory challenges, we're going to see kind of the standard stuff, right? Simple protocols that are well known, and these are the ones that are probably most appropriate for like an introductory cybersecurity class. If you use a CTF along with your class and you're teaching students about networking stuff, then bringing them into a CTF and showing them some of those protocols in real network traffic, I think is pretty cool for them to be able to see. And I'll mention something about this challenge type as well. So it's networking challenges, and in the CTF that we're playing has a challenge category that is networking. Oftentimes in CTFs, especially sort of collegiate CTFs, the networking challenges will often be part of the forensics challenge category, because a lot of what we're doing here really is network forensics, right? We're analyzing recorded traffic to see what happened in the past. That's what a lot of digital forensics investigators do, is they look at old packet captures. At Virginia Tech, we store logs for the networks, and we also store some packet capture data so that if something bad happens in the network, we can do some investigation, and that's all part of the forensics activity, right? So sometimes you'll see networking category in a CTF, sometimes you'll see networking challenges under the forensics category. So a lot of what we do in CTF is we analyze, again, either live network traffic, or in most of these remote CTFs, we're analyzing a packet capture file to find a flag. And so we'll take a look at some of that today. Sometimes you're just answering questions related to the network traffic. Sometimes you're carving images and other files out of packet streams. So we'll get to that. Probably not today, but maybe next week we'll see. Obviously, if I set up a network connection with somebody, like if I connect to a web server, and if that web server sends me a file, or if I download a file from the web server, or if I visit a web page that has an image in it, which is about just about every web page we see nowadays, right? Of course, that image file has to come through the network to get to me. And if I have a recording of that interaction between my device and a web server, then I can potentially, if it's not encrypted traffic, I can potentially carve that image out of that network interaction, right? And so we'll take a look at some of that probably next week. The primary tool we're going to use, the thing I'm going to talk about today, is a tool called Wireshark. It is a GUI graphical tool for analyzing network traffic. It's really super easy to use. It's available for the major platforms, Windows, Mac, and Linux. It's totally free, open software, downloadable from wireshark.org. I encourage you to download it from wireshark.org, or if you're going to have your students download Wireshark, have them go to wireshark.org to download it. If you just Google wireshark.org, there's places all over the internet where you can download the software from. But when you download it from some third-party site, then you may get something with it that you don't want, right? Like some adware or some other software that is just going to be problematic. So I encourage people to go to the wireshark.org website to download this software. Some other tools that you might use for networking challenges are TCP dump and WinDump. So these are command line tools. So if you're more of a command line person, you can use TCP dump and WinDump. They're very powerful tools. TCP dump you would use on a Linux or a Mac. WinDump is very similar software. You'd use it on a Windows system, or you could use TCP dump on Windows if you're using the Linux subsystem for Windows, which I use a lot. It's very, very handy to have a Linux command line on your Windows box. So if you're more into command line, you can use TCP dump or WinDump. There's another piece of software called ngrep. So if you're sort of a grep user, if you know how to use grep really well to search for data in files, there's software called ngrep, which searches for, it's very similar, except for it searches in network packet capture files. So you can search for stuff in network packet captures with ngrep. Pretty cool software. I'm not going to show you that today. We're going to stick to Wireshark, but these are some tools that you can use on networking challenges. All right, and this is Wireshark, right? This is a screen capture from Wireshark. I'm just going to sort of talk about the interface briefly, and then I'm going to go to a CTF challenge, and then we're going to use Wireshark to solve the CTF challenge, and then maybe we'll get to one or two more challenges that we'll use Wireshark to solve, and or at least to partially solve. So in the Wireshark interface, there is in the upper left-hand corner, there's the start stop button, right? So if you're gonna capture traffic live, then the way you do that is you click the shark fin button that starts a packet capture, and then when that's started, then this will get grayed out, and then the square here will turn red. And that's the stop capture button, and so that's how you start and stop network traffic captures. If you're examining a packet capture, then you don't have to worry about starting and stopping the packet capture. In the middle panel here, you see packets. These are the individual packets, and each one of these has a sequence number, right? So I'm not at the beginning of this packet capture, because when you start Wireshark doing a live capture, the first packet that it captures is going to be packet number 1, and then packet number 2, number 3, right? So they're captured in sequence. And so here, this particular packet capture file, you know, the packets I'm seeing here now are packets 386 through 396. And so you see each line is a single packet, and you see the sequence number, you see the timestamp. So this is the time in seconds from the beginning of this particular capture. You see the source IP address, the destination IP address, you see the protocol, you see the length of the packet, and then you see information. So this is generally the application layer data that's in the packet. So each packet is going to be listed here in the middle panel here in the Wireshark interface. And then if you select any packet, what you see down here at the bottom is this is the TCP/IP network layers. And I'm not going to talk about TCP/IP today because that's just I'm talking about CTF challenges and solving CTF challenges, but that's a little bit of background that you should have coming into solving network CTF challenges. It's helpful to have a little bit of background in the TCP/IP layers. But what you see here is for whatever packet that you select, you see the physical layer protocol data, then you see the link layer. Sometimes you hear that referred to as the MAC layer protocol data. So you have the hardware address for both the sender and the receiver. So the source hardware address, the destination hardware address. And then the third, the middle here is the network layer, or sometimes you hear this referred to as the IP layer. This is the internet protocol addresses. So here's a source address, 10.1.48.149 should be a very recognizable IP address, right? And then here's a destination address. And then the next layer is the transport layer. So this happens to be a UDP packet, user datagram protocol, and it's destination port 53. So here at the application layer, we see that it's a DNS packet, right? Domain name system. So the application layer is at the very bottom here. So you see the whole TCP/IP stack, and then if you click on one of these arrows, then it's going to break out that particular layer, and you're going to see all the details of the protocol data at that layer. Okay, so I'm now going to go to the CTF, and we're gonna take a look at this live, right? So here's the weekly workshop CTF. Again, it's vacr.io/weekly workshop. And I'm going to log back in. And here we are. So these are some of the cryptography challenges that we looked at last week. Today, we're going to look at networking challenges. So I click on the networking tab here. And the first challenge is very introductory, right? 10-point challenge. It's called Ethernet to IP. And if I click on the challenge, let's see if I can make this a little bit bigger. So here's the challenge, right? What is the internet protocol address of the host at, and then it gives a hardware address, 00:50:56:ed::C2:E2 in the attached packet capture file. And then there's a couple of hints here. The IP address is a sequence of 4 numbers between 0 and 255 separated by periods. Okay, so that's helpful if I don't know what an IP address is supposed to look like. It's 4 numbers separated by periods. Hint number 2, use Wireshark for this. It's available for download at https://wireshark.org sharp download. If you have a Virginia Cyber Range exercise area account, you can use Wireshark, right? So if you're using this with your students, you can have your students log into the Virginia Cyber Range. They can go to the CTF inside the Cyber Range, and they can use Wireshark in there. I'm going to use it on my Windows desktop computer. Okay, so there's even a hint here. Look at that. This is a super great intro challenge. So here's lookup.pcap. So this is the artifact I'm going to interact with. I click on lookup.pcap, and it gets downloaded. So it got downloaded, and so it's in my downloads folder now. My Chrome browser gives it to me handy dandy up in the upper right hand corner. So I'm just going to click on it there, and it knows to use Wireshark, right? So I've already installed Wireshark. And I'm going to zoom in a little bit. So you can see it better. Okay, so this is Wireshark, very simple. And what I see is what I showed you on that previous slide, right? So I see individual packets up here at the top, and this is super simple packet capture. It's only got two packets in it. This is pretty weird. Usually, if you just start capturing, you're gonna capture dozens or hundreds of packets in a few seconds. In this case, I took an existing packet capture and I pulled out two packets that I wanted to use, and I threw away all the rest. So all I got is these two packets, right? An outbound request packet and an inbound response packet. So here I see the sequence number 1 and 2, then the time, the source IP address, the destination IP address. These are DNS packets, right? So this is a DNS query and response. And I can actually see the entire thing from the top here, right? I queried for wired.com. So I did a DNS lookup for wired.com, and I got a response from my DNS server, and here's the response, right? Here's IP addresses that are useful for that. So I see the packets up here at the top. In the middle, I see again, I see the TCP/IP stack. So here's the physical layer protocol data. Lots of interesting data here. When your students take a networking class, they'll learn more about all this stuff. I see the hardware layer. So destination and source hardware addresses. I see the IP layer. Move this up so I can see more of this. But I see the source and destination IP addresses. I see it's a UDP protocol. It's a user datagram protocol. It's a UDP packet, and then it's a DNS. It's DNS traffic, right? Query. This first packet is a DNS query. So I'm going to go back to my challenge here and see what I'm trying to find. I need to find the protocol, the IP address of the host at 005056 ED C2E2. Okay, so the end of it is C2E2. So if I look down here at the bottom, I see that the destination is C2E2. And so if I look at the IP layer data, I can see that the destination address is 192.168.28.2, right? Destination, it's right here, 192.168.28.2. So let's go back here. It's, 192.168.28.2. And I'm going to submit that. And that's the flag, right? So all I had to do here was I had to match the destination hardware address here that I was given in the challenge description. I had to match the destination hardware address with the destination IP address, which is right here, 192.168.28.2. So here's the destination address down here at the bottom. So that's very simple networking challenge, and that's how you use Wireshark to dig into something like this. So questions on this challenge? I'm going to look at a couple of more here. You have some time. Okay, super simple. Okay, the next one is Mac Who. So this is very similar, right? This is I'm not going to solve this one. This is left up to the viewer, but again, this is a similar challenge. It just gives you a little less information, right? It doesn't give you those hints that you had before. So what's the MAC address of the system that has this IP address? And this capture is probably going to be more complicated, right? Lots more packets. So you have to do some filtering to find this particular IP address. And then once you find that particular IP address, maybe I will do this one really quick, just so you get the a little bit more Wireshark intro. Again, I'll blow this up, right? So this is a much more complicated packet capture. Here, there's many hundreds of packets, maybe thousands of packets. Okay, it's 1,161 packets. So this is not so easy because, you know, when I only had 2 packets, it was super easy for me to find the hardware address I needed so that I could find the IP address. And this one is maybe not as easy. I don't know, this might be it right here, but 192.168.9.128. So I'm going to copy this IP address because I'm going to go back to Wireshark here, and I'm going to show you how you use a filter to find a particular piece of data that you need. So I'm going to go up to the top of the Wireshark window, and there's this filter bar. So right now I'm seeing a whole bunch of traffic, and maybe I want to filter so that I only see particular traffic, and the traffic I want to see is traffic that has that specific IP address in it. And so I'm going to use a filter. So I'm going to use IP.adder, IP.address, IP.addr, and then I'm going to put a double equals, and then I'm going to paste in that IP address. I'm going to talk next time a little bit more about Wireshark filters. But what I can use a filter for is I can filter traffic so that every packet I see has that particular IP address that I wanted, right? So it's this one, 192.168.9.128. And now that I've narrowed down my my data set, now I can easily find the packet that has that IP address. Now I just go down to my you know, I do the same thing again, right? I go down, this is the source IP address. So I go down here and I find the source address, and I put that in as the flag, and that's going to give me my points. Here's another fun challenge. It's called unsafe protocols telnet. So let's go to that challenge. Got a couple more minutes. So I mentioned protocols, and one of the protocols I mentioned was telnet. So this challenge, I'm sure, is going to have a telnet, some kind of traffic in it. Telnet is a old terminal utility where I could connect to a computer on the other side of my network, or I could connect to a computer on the internet. Using, if that computer accepted telnet connections, then I could connect to it from my own telnet client, and it's really super handy. The problem with telnet is that it's in the clear, right? So there's no encryption on telnet connections unless you're doing it through a VPN or something that's going to layer encryption on top of what you're doing. So nowadays we don't use telnet anymore. Most people don't use telnet anymore. You still see it out there once in a while, but mostly we use SSH instead of telnet. But with telnet, I can connect to a remote host, and so this packet capture is a telnet interaction. So it says, learn some things about the wonders of insecure protocols. The answer is what's inside curly braces, and there's another packet capture to download. So I'm going to click on the packet capture file, and I'm going to open it up in Wireshark. And so what I see here is a whole bunch of traffic, not that much, 165 packets. So it's some web traffic, or it's some network traffic, and so this is a fairly simple packet capture file. It doesn't have thousands of packets. It has a couple of hundred packets. Up at the top, I see some you know, these red things are reset packets. So the stuff that's red is usually not very useful. What I do see is, if you're familiar with the TCP/IP protocols, what I see here is I see a SYN packet, and then I see a SYN and an ACK packet, SYN, then SYN-ACK, and then the third packet here is an ACK packet, an acknowledgement. So this is what's called the TCP three-way handshake: SYN, SYN-ACK, ACK. So if you've heard of that but never seen it before, that's exactly what this is, right? So this is a client creating a connection with a server, and the source address and the destination address are 127.0.0.1. So it's the same source and destination address, and this address happens to be the loopback address. So it's a computer connecting to a telnet server that's running on itself, right? So it's one computer connecting to itself. This isn't even traffic that would have gone out over the network, but it's network traffic, so you can capture it. And I know that's supposed to be, I know this is supposed to be telnet, or I can assume from the challenge it's supposed to be telnet traffic, right? So I see a network connection that's being set up. SYN, SYNAC, ACK, that's probably interesting. And here it is again. Here's another SYN, SYNAC, ACK. Okay, so it looks like two different network connections are being set up in this particular interaction. And so if I see this kind of an interaction, SYN, SYNAC, ACK, I know that a TCP connection is being set up. A cool thing that I can do in Wireshark is I can right click on any of the packets in this exchange, right? These are all packets, you know, this is all traffic going back and forth between these two hosts after the TCP connection has been set up. So I can assume that this is all part of that same TCP session. And then at the end, I see a push at an ACK and I see a fin ACK. So this is going to shut down the TCP connection. So all this in between is one TCP connection. And if I right click on it, I can go down to a thing that says follow in my context menu, follow, and I'm going to follow the TCP stream. And what I get from Wireshark is a new window. This, it seems like I can't blow it up. I can't blow this up. So I'm not sure how to make it easier to see. But if you look here, it's a bunch of messages sent from one system to another. So the red is one host, you know, one host sending traffic. The blue is another host. So oftentimes you'll see a bunch of red interspersed with a bunch of blue, depending on the kind of traffic it is. This is just one host sending a bunch of stuff, and then another host sending some stuff. And so it says, you know, it's just a goofy message. Hello, do you know what telnet is? It's an old protocol where the flag is, and then, you know, blah, 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 blah. And then it says, here's the flag. Sorry for making you wait. And then it's got this thing. And then it says, oh, wait, that is a non-standard encoding. Hope you can figure that out. Okay, so here's the flag, right? So I can copy that and I can paste it into Wireshark, or I'm sorry, into my CTF, and I can submit it, and it's going to fail because it's not the flag, right? But we know that it's pretty close to the flag. So what is it? What do we think this is? This is not the flag, but it's an intermediate step to the flag.
It's base 64.
Base 64, yeah. How'd you know that, Bob?
Do I do this for a living?
Right,
that's probably the only reason why.
Because you see a lot, yeah, right, exactly. And that's a great answer, because that's why I think this is a good, a lot of CTFs, you're going to see something that's base 64 encoded. Why do you see that? Because if you're a cybersecurity professional, you got to be able to recognize base 64 when you see it. And that's what this is. So how do I decode it? Well, I can go to many different websites. One of them is ASCII2hex.com, or I could do it at the command line. I'm not gonna do it at the command line, but I can go to ASCII2hex.com. We talked about this website last week during the crypto stuff. I can go to the base 64 box and I paste in that thing. It has an equal sign at the end, which is a sort of a dead giveaway that it might be base 64. I click convert, and here I see in my text section, it says flag, and then it has a curly bracket, and there's the flag, right? So now I'm going to copy that, and I'm going to paste that in here, and I'm going to submit, and that's going to give me my points. All right, I'm going to stop there because I'm at almost 30 minutes, and we'll pick this up next week. I'm going to talk about a couple of more networking challenges, but let me see, before we sign off, let me see if there's any questions or comments on any of this. All right, great. So next week, we're going to pick up and do a couple more networking challenges. Maybe we'll look at a couple more techniques for solving that are not just using, I mean, Wireshark's a great tool. You use it a lot, but there's other things that we might use to solve some networking challenges. So we'll take a look at some of those tools maybe next week. And so thanks for joining. We'll see you next time.